Hi, guys. Okay, so let's do chapter 3 homework, and we are going to cover 3.1 to 3.3, 3.1 through 3.3 sections, and that relate to the content that is, up till page 72, and that is up till the temperatures. So sections 3.4, 3.5, 3.6, and 3.7 for now are optional. However, at some point, I am going to be covering the content from these sections that relates to, the reactions, and that's, later chapters. And then for now, if you want, you can do the questions on your own. So those are options, okay? So now let's look at the page 66 problems, page 66 problem, chapter, like the problem 3.1, 3.3, and 3.5. And then after that, I'm going to look at page 69, problem 3.7, 3.9, 3.11, and 3.13. And then page 72 is 3.17, which relates to using the formula to convert the temperatures from degrees Celsius to Fahrenheit and Fahrenheit to Celsius and so forth. So I'm not going to do this because I already covered that in the lectures. But all these questions are going to be, in a way, lecture oriented so that you can understand them more. Okay. So hold on. Okay, so let's look at the problems in 3.1. Okay, so all of them we will do here because, these are simple problems. Anyway, so classify each of the following as a pure substance or a mixture. That is 3.1, part A. Baking soda. Is it a pure substance or a mixture? So baking soda. Now, here's the thing. Every time you see a formula like this and there is nothing else, mixed with it, baking soda, that's the common name of sodium bicarbonate. So this is a pure substance. So for pure substance, I'm going to write down P, and for mixtures, M. Okay, so that's a pure substance. Now, ice is common name, but water, like H2O, H2O is the formula for that. Now, H2O, water, is a pure substance if it's not mixed with anything. So here it's just ice. Ice is a different form of water. In other words, you take the liquid water, and if you change it, if you bring the temperature down, you freeze it, it becomes ice. And it is just a phase change, but it is not a new substance. In other words, it is a different phase, but the chemical composition still remains the same, and it is not mixed with anything. So it is still pure. So the chemical component is the same, even though the water exists in a liquid or in the ice state, or even in the vapor state, it will still be a pure substance. Okay, now comes the trimix. Mix oxygen, nitrogen, and helium. Obviously, these three different types of gases are mixed, so they are mixtures. Okay. Next is a blueberry muffin. Although blueberry muffin is it's a little bit tricky because, final product after baking and mixing and, after making it, after final whole chemical reaction is done, after cooking, it becomes a pure substance as a blueberry muffin. But before cooking, when you're mixing the ingredients, so those are mixture. So I'm going to, at this point, assume that blueberry muffin is after cooking. And although it's a new substance is formed. Okay. So in this case, for instance, you can also look at it as a mixture if you put something on the blueberry muffin. But if it is just a pure blueberry muffin, then it is it's just a muffin by itself. Like every part of the muffin is going to taste the same. So it's a pure substance. Okay. But mixture is before baking. Okay. Zinc is the name of a metal, and it is a pure substance. It's not mixed. Okay. So that's one piece. Now comes 3.3. Classify each of the following pure substances as an element or a compound. So element, remember elements, these are found in periodic table. The elements that's why it's called periodic table of elements. So these are found in the periodic table. Compounds are a mixture of two or more elements. They are chemically combined. Okay. So silicon, a silicon is silica. You can see in the periodic table, it exists as Si. So this is an element. Oxygen. Now, 2 atoms of oxygen are compounds. 2 atoms of oxygens have been bonded together, O2. You are not going to find O2 in the periodic table. You will only find O. The O that you find in the periodic table is atomic O, but O2 is molecular O, which means 2 atoms of oxygens have bonded. So this is M, molecule. And so this is actually a molecule. So molecule, in a way, compound. Okay. Methane. Again, methane, you are not going to find CH4 in the periodic table. You will find C, you will find H only, not even H4. So carbon combines with 4 hydrogen. So it's in a bonded state. Okay. So this is a compound, rather a molecule, right? The smallest particle of a compound is molecule. Hydrogen peroxide, same thing, chemically bonded hydrogen and oxygen, molecules. So this is a compound. And Fe2O3, iron oxide, rust, again, bonded atoms of iron and oxygen in 2:3 ratio, and that becomes a compound. Okay, now comes 3.5. Classify each of the following mixtures as homogeneous or heterogeneous. Now remember, homogeneous is when they look one. When they look one. Heterogeneous is when you can see 2 or more components. Okay, 2 or more components can be seen. So here we see vegetable soup. So vegetable soup, if you've seen the vegetable soup, you can see, the chunky, the parts in a vegetable soup. So this is a heterogeneous mixture. So here heterogeneous, I'm going to put as HT, and homogeneous HM. Okay, so vegetable soup is heterogeneous. Tea. Now, tea, when you put the tea, like it all looks the same. So even though, tea has like, let's say milk or sugar and maybe some other, like a masala tea or something, then it's homogeneous still. So this is a homogeneous. Now, fruit salad, lots of fruits you can see. So heterogeneous. Okay, then seawater. Now, seawater obviously contains the salt and water, and then it has all these other impurities also. Very clearly, it's impure. So the seawater is heterogeneous. Tea with ice and lemon slices. So obviously different. So in this case, the tea is heterogeneous. Okay, so that finishes 3.5. Now let's look at the next ones, which is here, 3.7, 3.9, 3.11, and 13. Okay, here, indicate whether each of the following describes a gas, a liquid, or a solid. Okay, a gaseous breathing mixture in a scuba tank that has no definite volume and a shape. So the question here in 3.7a is talking about gaseous. So obviously it's a mixture of gases, no definite shape, no definite volume. So it's a gas. A neon atom, the neon atoms in a lighting display do not interact with each other. So neon atoms, neon is a noble gas. So you should know this. This is a noble gas. Neon signs, okay? So the names of the noble gases: helium, neon, argon, krypton, xenon, radon. Okay, so all those, okay? Next is the particles. The particles in an ice cube are held together in a rigid structure. Rigid structure only applies to the solids. All right, so that thing. Next comes 3.9. Describe each of the following as a physical or a chemical property. Okay, now physical and a chemical property, right? Property that defines a substance, whether it's physical, what is that substance, and that properties can be physical and chemical. Now remember that physical properties depend on your 5 senses. How a substance looks, how it feels, how it tastes, how it sounds, how it smells, right? So physical properties are based on your 5 senses. Besides that, the physical properties also are whether a substance is soluble in water, whether a substance is a good conductor of heat, electricity. Can you beat the substance and make it into thin sheets? Can you stretch that substance and make it into wires? All right. So those things. And what is the density of the substance, right? What is the more you will study about, what the specific heat of the substance is, those things. So those are all physical properties. Chemical properties are, how does a substance react? Does it react with each other? Does it react with, let's say, oxygen? Does it react with water? Does it react with hydrogen? Does it react with acid, with a base? And if it does react, what kind of reaction is that? Like, what kind of reaction is it producing? Is the reaction exothermic, releasing heat? Is the reaction endothermic, which means absorbing heat, right? So what is that substance? Basically, what is that substance like behaving in what's the environment, in the chemically, what does it produce? And sometimes it's not like no reactions occur either. So it may not react. That's also a chemical property, okay? All right, now let's look at 3.9, describe. Chromium is a steel gray solid. So you see the steel gray is the color. So you're just looking at it. So this is a physical property. So physical will be P and chemical is C. All right. Hydrogen reacts readily with oxygen. So it's obviously a reaction. So we are looking at the chemical property. A patient has a temperature of 40.2 degrees Celsius, 40.2 degrees Celsius, physical property. All right. So that's a physical property. Just the temperature is basically the amount of heat a substance has. In this case, it's a human being. So regardless, the amount of heat that is present in a system. The milk will sour when left in warm room. Now, souring is a chemical thing. So it's a chemical change. It's a chemical property. Okay. Next is butane gas in an igniter burns in oxygen. Burning is always a chemical property. Okay. So these are the chemical properties of the substances. Now let's look at 3.11. What type of change, physical or chemical, takes place in each of the following? Okay, now we are looking at the change. Okay, now when you mix things, what happens, or when you perform certain actions? So physical change, P, chemical change, C. Water vapor condenses to form rain. So water vapor is a gaseous state of water. And rain is the liquid state of water. So basically, you're taking water, converting it from the gaseous state to water in a liquid state. So that's condensation, is just the change in temperature at a lower temperature. Okay, so this is a physical change. Physical change only. Okay, cesium metal reacts explosively with water. So reacts, obviously, chemical change. Reacts, it's a chemical reaction. Gold melts at 1064 degrees Celsius. Melting, physical change. Okay, a puzzle is cut into 1000 bits. So simply cutting is just changing, the physical appearance of the substance. So a puzzle is cut into 1000 pieces. So just a physical change. Cheese is grated. Once again, a block of cheese versus the grated cheese. It's still a cheese. The chemical composition does not change. So it's a physical change. No new substance is formed in a physical change. Okay. Next, describe each property. That's 3.13. Describe each property of the element fluorine as physical or a chemical. So now we are looking at just one element, fluorine, and we're going to look at its individual properties. Highly reactive, part A. Highly reactive. Highly reactive means it's obviously a chemical change. Reaction is always chemical change. In a gas, is a gas at room temperature. So gas at room temperature, that's just a physical state, right? Physical property. Then has pale yellow color. Again, color is physical property only. Okay. Will explode in the presence of hydrogen. Explosion is a chemical reaction. So chemical change. Has a melting point of negative 220 degrees Celsius. Melting points, boiling points, freezing points, all chemical are all physical changes. Okay. Now that's the part here. So the last part you guys have to do, and I'm not going to do is the temperature, and I believe it's 3.17. Okay, these are given to you. Calculate the unknown temperatures in each of the following. In other words, you have to convert 37.0 degrees Celsius to Fahrenheit, Fahrenheit to Celsius, negative 27 degrees Celsius to Kelvin, degrees Celsius to Kelvin, and 114 degree Fahrenheit to Celsius. So this is, I have in the handout, the formulas. Okay. All you need to do is plug in these numbers and the formulas and you will get the answer. So not very complicated. So this I'm going to leave up to you to do. And then I'm going to look at your answers if they're correct or not. But you can also check your answers at the back. But however, here when you do it, you need to show steps in working. And here, refer to the handout for the formula. Okay. And if you cannot do it, then you can always ask me, but I'm pretty sure you can. Okay. All right. So this finishes this homework session. And if you have any question, please ask me. Okay. Thank you. Bye-bye.